Hi everyone, so this is the video for the introductory section of the Pythagoras Theorem unit. So Pythagoras Theorem is a theorem that comes from a right angle triangle and the relationship that exists between the three sides of a right angle triangle. So to review, let's remind ourselves what a right angle triangle is. So three sides, and one of the angles in that triangle is a right angle, so a 90-degree angle. So within that triangle, Pythagoras' theorem states that when you have the three sides, the longest one being opposite to the right angle, referred to as the hypotenuse, so that might be a new vocabulary word for you. So the hypotenuse is always the longest side of a right angle triangle, and it is always the side that is opposite to the largest angle, which is your right angle. So when you have your hypotenuse, if you square it, multiply it by itself, that is equal to the other two sides squared and added together. So in Pythagoras' theorem, C is always going to be your longest side, your hypotenuse. And then the other two sides, the shorter two sides, are just labeled with A and B. It doesn't matter which one is A and which one is B, because it would be the same squaring them and then adding them together if you relabeled them the opposite way. So Pythagoras' theorem, A squared plus B squared, the two shorter sides squared and then added together, is equal to that third side, the longest side, squared. So this is the relationship that exists between the sides of a right angle triangle. So if you know two out of the three sides, you can use Pythagoras' theorem to solve for the third one. So down here below, we have sort of the geometric sort of representation of Pythagoras' theorem. So we kind of understand squaring the sides, adding them together, but if you want to think about it in a sort of visual sense, it is the area of the square on the hypotenuse is equal to the sum of the areas of the squares on the other two sides. So if we take this triangle in the middle here, this right angle triangle, and we square the two shorter sides, right? We literally make a square out of the length of the two shorter sides. So area, we'll remember, of a square is base times height. So because it's a square, that base and that height are going to be the same measure. So if we find the area of the squares created by the two shorter sides, add them together, that is going to give you the exact same area as the longer side, the hypotenuse squared. So if you want to think about it that way, that's great too. It's just a sort of a geometric kind of way of thinking about it. We will traditionally, in this grade level, focus on just using the algebraic formula in that way. We won't necessarily think so much about it in a geometric sense, but I wanted to kind of make that clear to you as well. So we're going to go through two examples. One example where we are finding the longest side, and then one example where we are finding one of the shorter two sides. So if we look at the first example, it says find the length of the hypotenuse in this right angle triangle. So we've got a right angle triangle diagrammed here. We see that one of the shorter sides is 3 and the other shorter side is 7. The key to using Pythagoras' theorem is making sure you get the hypotenuse in the right place. That's the only side in terms of a labeling perspective that really, really matters, because the other two can be A or B. So you always want to start at your right angle and go across your triangle. Opposite to the right angle, that is your hypotenuse. So as long as you make sure you get that labeled in the correct spot, then you should be all right. Okay, so we always begin a formula question by writing out the formula. A squared plus B squared equals C squared. Then the next line of work, we want to put everything we know in the right place. So 7 and 3, our two shorter sides, are A and B interchangeably. Doesn't matter which one's A, doesn't matter which one's B. So I'm going to put in my 7 as A, my 3 as B, and I am solving for side C. I can say that my hypotenuse is C. I could also use X. I could use any letter I want. I'm going to use C because it's just what came from the formula itself, and this diagram didn't have an X pre-labeled. So then the next line of work, I'm going to do all the math that I can, which is going to be to square those two sides. So 49 is 7 squared, 9 is 3 squared, and I still have my equals c squared because I am solving this equation. So then I'm going to add together my 49 and my 9, and that's going to give me 58. So now I know that 58 is equal to the hypotenuse squared. And then to figure out what just c is, I have to do the inverse operation of squaring. So the inverse operation of squaring is to take the square root. So I'm going to take the square root of both sides, which leaves me with just c on the other side. And then I would go to my calculator, find the square root of 58, and I find that to be 7.61577, and then there's some more digits there. So traditionally, unless the question asks you otherwise, you're going to want to round your final answer to 3 significant figures. So let's review that. So first, non-zero digit is where we start counting. So 7 is my first significant figure, 6 is my second, 1 is my third, and then after that, I'm going to cut and round appropriately. So that 5 on the other side of the line that I've drawn will bump up that 1. So my final answer will be 7.62 is approximately equal to c. I use the approximately equals because once I've rounded it, this is no longer an exact answer. This is now approximately. And then the final thing we want to do is look at our units. So our units are in centimeters. So we could say the hypotenuse is approximately equal to 7.62 centimeters. Okay, so that's the most basic traditional form of using Pythagoras' theorem, to solve for the piece that is on its own on the other side of the equal sign. So this next example, we're going to look at solving for one of the shorter sides. So this one says, find the length of the third side of this right angle triangle. So we always want to begin with labeling our triangle. So across the right angle, or across from the right angle in our triangle, we find our hypotenuse. So 10 is our C value. So then the other two sides can be labeled A and B. It doesn't matter which is which. So I will make the side I am looking for A and the side that I already know B. You could do the opposite. It is totally fine. So then to Pythagoras I go. So again, beginning with a squared plus b squared equals c squared. Then our next line of work, we're going to insert everything we know. So I don't know a, so that's the part that's going to remain a variable in this equation. Plus b I have discovered to be 4, so square that, equals to c, which is 10, so square that. So then the next line, I'm going to square the numbers that I can. So I've got a squared plus 16 equals 100. And now I need to isolate for a. So I need to get everything away from a and just have that left on its own. So to do that, I'm going to subtract away my 16 from both sides. What I do on one side of the equal sign, I do exactly the same thing on the other. So now that leaves me with just a squared on the left, and then on the right, I have equals 84. So now to figure out what just a is, I need to do the inverse operation of squaring, which is square rooting. So I'm going to take the square root of both sides. So that leaves me with a is equal to, and the square root of 84 on my calculator is 9.1651. So I'm just going to throw a couple of extra decimal place values in there. And then because the question doesn't state how exactly it wants the question rounded, I'm going to default to 3 significant figures. So begin counting at the first non-zero digit. So 9 is significant figure 1, 2, 3. Then I'm going to cut and round appropriately at that point. So A is equal to 9.1, and the 5 will bump the 6 up to a 7. Then I grab my units from my diagram, which is centimeters. So the third side is equal to 9.17 centimeters. And that's it.